So we're gonna start section 3.2, and that discusses roles and the mean value theorem. So those are two things that we're gonna discuss in section 3.2. And they are not that hard. They are really not that hard, because once you understand the theorem, the application becomes pretty simple. Remember what we discussed in chapter 3.1, right? The extreme value theorem. Can anybody remember how to recall it? Can anybody recall it? The extreme value theorem?
Nope. Yeah.
Yeah? So what is it?
I have it on the paper. It's like if f is continuous on the closed intervals, then f has both the minimum and maximum.
Maximum, right? That's it. So that's the Rolle's theorem is almost like an extension of that. So we're gonna add some more things. Now if you look at the picture here, right? Tell me what you notice. Tell me what you see.
I see that there's a minimum and a maximum.
There's a minimum and a maximum, that's true, right? You also notice that what?
Interval.
It's a closed interval, right, on the segment, and you also notice there's a point C here that I added, right? Now, if you look at this function, what would you say about, let's say I was to find f of a, what would it be? Let's call this D. What's f of a? D, right? And what is f of b? D. They're the same, right? They're the same because f of a and f of b are similar. I mean, the word similar does not apply. They are the same thing, right? So Rolle's theorem says this: if f is a continuous function, right, on AB, is f continuous? Yes, right? There's no gap on between A and B. If you go, there is no gap or nothing like that, right?
Like a paper.
All right. F is a continuous function on the closed interval AB, right? And f is also differentiable on the open interval AB. Is he differentiable on the open interval? Yes, right? Because you can find the derivative of a parabola. You can find it. So if f of A is equal to f of B, then Rolle's theorem says that then there exists a point C in AB such that f prime of C is equal to 0. That's Rolle's theorem. Meaning, if you have a continuous function over a closed interval, and if at those given extremities, like at the end point, f of A and f of B, those are the same values, they give you the same thing, then Rolle's theorem says that there exists forcibly a point C such that the derivative at C is equal to 0. And that proves it itself. You see what you have here. What's the derivative at C? What do you think?
0.
0, right? So Rolle's theorem says that this is what happens. If you have a function that is continuous on a closed interval, and if that function is such that f of A is equal to f of B, meaning if you value the function at its end point and they give you the same value, then surely there's a point C in AB such that f prime of C, meaning the derivative at C is equal to 0. Does that make sense?
Seems easy enough.
Yeah, well, it's just application. But now, take a look at the next function here. What would you say? Would you say that Rolle's theorem will apply? What do you think?
No.
Well, let's break it down, right? Let's go through the steps. Is f continuous on AB?
Yes.
Let's go. So it's continuous. Yes or no?
Yeah.
Yes. Continuous? Yes. Right? It's continuous. Now, is f of A equal to f of B?
Yes.
Yes.
Oh wait. Oh, I know why this. Okay, I know why. What's going
Now, what is the problem? Yes, sir.
The derivative of f of c doesn't equal 0.
Doesn't equal, so it does not exist, right? So here, what do you have here? If you want to find f prime of C, what would it be?
It would be d and e.
D and E does not exist. So if one fails, then Rolle's theorem fails, right? So therefore, f prime of C is not equal to 0 because this is not differentiable. So that's what you want to say. The function is not differentiable because you have a vertical what? Vertical tangent line, right? So therefore, the function is not differentiable. So one of these things fails. F is not differentiable on the open interval AB. So therefore, Rolle's theorem fails. All right. So it's pretty easy step. So we're gonna do some applications, and then we're gonna call it a day. Okay. Now let's start with, I don't know, are we on the same page, Adrian?
Yeah, I'm still trying to get a pencil real quick.
Alright. I'm gonna try to get this up there maybe by the end of the day, if I can. Let's try to see if you can work on these problems. Okay, so if you look at this function here, f of x is 1 over x between negative 1 and 1. Would you say that Rolle's theorem will apply? Think about it for a second.
Can I put it in my calculator and see what the graph?
Well, you can put it in the calculator, but based on Rolle's theorem, do you think this will work? First, what has to happen?
No.
Why?
Because x is in the, because it would be D
DNA of what?
on C.
See, now see, look at it. First, we have to make sure the function is what?
Continuous.
Continuous. Is it continuous?
No,
Where?
as a zero.
At x equals 0, if you see the domain of this function, right? You see it? What if I want to find the domain of this function, what would it be? I do not want x to be what? Equal to 0, right? So if x is equal to 0, the function is going to have what there? We're going to have a vertical asymptote, right? There's going to be a gap there because 1 over 0 does not exist.
So do you mean like the second graph is not continuous?
This is continuous. That's continuous.
There's also like a,
It's a vertical asymptote.
oh,
This is, vertical tangent line. Here, you have a vertical asymptote, meaning x cannot equal 0. Here, the derivative cannot equal 0. But here, the function itself cannot equal. Do you see it, Kevin? Because it's not continuous here. Do you see it, Adrian? Because 1 over x, if you were to draw that function, draw it on your calculator, you see what's going to happen. Don't even draw absolute value, just 1 over x. If you draw 1 over x, you're going to have something like this, probably something like that, or like that.
Well, doesn't even touch the line.
It's a third line because you have a vertical asymptote, right? So therefore, since one of these fails, we don't even have to do the rest.
So
Because-
it's not continuous because it doesn't touch like anything.
It doesn't, yeah, you have a vertical asymptote. X is not, the function is not defined as 0.
Wait, what does it mean by continuous again?
Continuous means there is no gap or there is no break.
Oh,
So-
so there's two lines.
Two lines like this is continuous. That here is not continuous because look, what do I have here? I have a
There's a
hole.
break, there's a break there.
That's a break, right? And if I have this, I have a break here. So therefore, this is not continuous. So we don't even need to check for the other ones. Because f is not continuous because at x equals 0, you have a hole or a vertical asymptote, right? It's either one of those. Does that make sense? Yes? All right. Second, what would you say about this function here?
It is continuous. Oh wait, no, it's not.
What do you say?
It's not, because if x is 0, then
Yeah?
it would be 1 minus 1.
Yeah, that's fine.
it's fine.
It's not in the denominator.
Oh, yeah.
Right? But what can we say about this function? When you have an absolute value function, what does that look like? If you draw this function, right, I'll show you what it looks like.
There will be a vertical asymptote.
Vertical asymptote because the absolute value of 1 minus x minus 1 will look something like this. It will look probably something like this
Like there's a shift.
because it's an absolute value function, right? And when you have a function like this, what do we say about the tangent line?
Do you need?
DNE.
Oh, do you need because of that point on top?
Point, right?
Yeah.
It's pointing, so you're gonna have a vertical tangent line, so
So-
therefore it's
so-
not differentiable.
Yeah, so
How do you know that it's pointy?
Because-
Just by looking at the equation.
well, yeah. Should we just graph it like in a calculator?
Yeah, you can graph it in a calculator.
Figure it out. Okay.
You know, you start, or you can just use algebra 2. We start with a function absolute value of x, right? And then we're gonna do what first? We're gonna shift it 1 to the right. You all remember this?
Oh, I remember that. Yeah.
Right? You move it to the right 1 time,
Mm-hmm.
and then
How do
after
you know-
that,
How do you know it's not
Does
curved?
you flip it?
Huh?
Does you flip it too?
Flip it.
last year.
Yeah, I remember that. Yeah, like,
No, I remember letting you know about how do you know it's not like curved?
oh,
Because that, because
Well, it's x minus 1.
It's
it's a line.
This is like absolute value.
Absolute
Not
value.
the same, bro.
Alright, let's start with this, right? Let's start with this here. Let's start with absolute value of x, right? So, we know the absolute value of x can be negative x if x is what? Less than 0, right? And x is if x is positive. Because it's absolute value, correct? So when x is, now let's try to graph it. So when x is negative 1, this will be 1. When x is 0, it will be 0. When x is 1, it will be 1. So you start by graphing that,
Are you doing the third one?
No, the second one. We're here.
Wait, if x is 0.
X is 0, this is 0.
You-
I'm just starting by just grabbing absolute value of x, right? And then you can do some shifting. To draw x minus 1, 1 minus, we have to first shift it to the right 1 unit. Remember that? Variable shift,
I'm fucking with that kind of calculator.
right? Or you can use your calculator and then the next you flip it down. And then you're going to go up 1 unit, so it's going to be upward somewhere. So the final graph will be here somewhere. Now, because at 1 we have a vertical tangent line, the function is not differentiable. You remember every time the first derivative cannot be found because you have a vertical tangent line, therefore it fails Rolle's theorem. The f is not differentiable at 1. Does that make sense? You see it? Or no? If you don't see it, I'll go over it again.
I understand that.
Yeah, because every time you have an absolute value function, it means somewhere the function is not going to be differentiable at that peak. It's either going to be like a
Let's get
reverse
you,
peak.
let's get you D and E at that point.
Which-
So will it
Yeah.
always fail?
It will fail because it's not differentiable.
So whenever it's a absolute value,
Yeah.
it'll always fail.
It will fail. Well, it will fail, it depends on the interval. Between, as long as the C is in this interval, it will fail.
Right, as long as the peak
The
is.
C is in this interval, it will fail. Right? And then the last one is this. Now let's try this one here. We have f of x is negative x squared plus 3x, right? So is the function continuous over 0 and 3?
Yes.
Yes, a second degree equation, no problem, right? So continuity, we can say check. Second, what's f of 0? We need to find f of 0. F of 0 will be what?
It's 0.
0. And what's f of 3? We need to check it.
Be negative 9
Nine.
plus 9,
9, which is 0.
So
No. So that's also good, right?
Boom.
That's okay now. Okay, what's f prime of? So now we need to figure out is a function, is the derivative, is a function, can you find the derivative of the function?
Yes.
F prime of x is what?
0.
No, f prime of x right here.
Negative 2 plus 3. Or
Negative 2x plus 3, right? So if you see this derivative, is there any value that's going to make this undefined? No. Right? Does this exist?
Yeah.
Yes, you have a derivative.
So it works.
So it works. So therefore you can apply Rolle's theorem, right? Now to find C, what we have to do? We have to set this equal to what? To 0. That's it. We just go negative 3x plus 3, and x is 3 over 2, right? We just have to make sure that this falls into this interval. Does it? Yes. Right? So therefore Rolle's theorem applies for this function.
Oh, it's gotta.
Wait, so you find the derivative then?
So it's gotta be continuous first.
Yeah,
And
continue.
then once you find the continuous, you gotta plug it all in, make sure it equals.
Make sure f of this is equal to f of that.
Okay.
And then
And-
third thing,
Third thing for C, C has to be in the middle.
in the middle, and the function has to be defined at C.
When you find the
The second-
derivative,
the
then you
derivative
plug
has to
in
be defined.
0 to that, or you plug in whatever the 1 point was.
Yeah.
So both 0 and 3 equal the same thing?
Yeah, they have to be equal to the same thing. F of 0 has to be equal to 0. F of 3 has to be equal to 0 based on what we did. F of A and F of B have to be equal. That's the second condition.
Let me write it
And the
down.
third condition, if this is true, if these two are true, then yes, there is a C in A and B such that F prime of C is equal to 0. As long as these two conditions are true, the third one is true.
Okay.
Okay. Now, if one of these fails, you don't have to look for the second one.
Wait,
the
you
third
said,
one.
what was the last thing you said? Blah.
If this is true, right, and this is true, right,
Yeah.
then this is, and then the third condition, then, oh my goodness, if this is continuous, number one,
Uh-huh.
then we're good. Second, f of A has to be equal to f of B.
Mhm.
Third condition, f has to be differentiable on the open interval AB. Okay? Which means you can find the derivative of the function between 0 and 3 as long as 0 and 3 are not included. Which we say you can find the derivative of the function. If this is true, therefore there exists a C such that f prime of C is equal to 0. So three conditions to recap. function has to be continuous. Second, f of A has to be equal to f of B. Third, there has to be the derivative between A and B, open interval. If those three conditions are met, therefore there exists a number C such that f prime of C is equal to 0. Does that make sense? Alright.
Wait, so did you have to find derivative, or were you just doing that? Just
Do I have to what?
do you have to find
You have to, because
Yeah.
once you equal it, it has to be in between 0 and 3.
It has to be in between these two values. C has to be in between,
okay.
right? So if C is not there, then we cannot apply Rolle's theorem. Alright.